What if I told you that the colors you see every day are only a fraction of what's out there? That the brilliant red of a sunset or the deep blue of the ocean are just a small slice of a much larger, invisible reality? Now, what if I told you there's a color your eyes were never meant to see, a color that doesn't exist in nature, but a new machine can now show it to you? This isn't a trick. It's a new technology that's rewriting the rules of human perception, questioning the very boundary between our biology and our tools. For the first time, we're seeing the edges of human experience bend and stretch beyond their ancient limits. Think of every color you've ever seen. Now, try to imagine a new one. A truly new one. Not a different shade, not something between green and blue, but a color that sits outside the rainbow. Can you do it? It's almost impossible. But that isn't a failure of your imagination. It's a hardwired limitation of your biology. And it's a limitation that has just been broken. The prison of perception. To get why this breakthrough is so wild, you first have to understand how your eyes, and your brain, have always worked, and in some ways, held you back. Deep inside your retina, at the back of your eye, are millions of photoreceptor cells. Most of them are rods, which handle vision in low light. But the real magic of color happens in the cones. Most humans are trichromates, meaning we have 3 types of cone cells. Let's call them S, M, and L, for their sensitivity to short, medium, and long wavelengths of light. In everyday language, we think of these as the cones for blue, green, and red. Every single color you've ever perceived, from pale yellow to deep violet, is just your brain mixing a cocktail of signals from these 3 cone types. It's like a TV screen using only red, green, and blue pixels to create an entire universe of images. Your brain does the same thing, blending signals from your S, M, and L cones to paint your reality. But here's the catch. The sensitivities of your cones overlap. A lot. Specifically, the wavelengths of light that stimulate your green, M cones almost always stimulate your red, L cones, too. With natural light, there's no single wavelength that can ping your M cone without also hitting the others. Think of it like trying to play a single, pure note on a piano, but every time you press a key, adjacent keys get pressed down too, adding muddy, unwanted notes. Under normal conditions, nature has never been able to play a pure M note for your brain. This means a whole category of visual experience was, until now, just a theoretical idea. A color that's purely green, in terms of your cone signals, without any red or blue interference, was thought to be a ghost in the machine of our own biology. At least, it was. The hero's entrance, hacking the ISO. What if you could bypass these limits? What if, instead of pressing messy, overlapping piano keys, you could just pluck the single, pure string you wanted to hear? That's the revolutionary idea behind a new system from researchers at the University of California, Berkeley. They call it Oz. The name is a fun nod to The Wizard of Oz, where visitors to the Emerald City had to wear green-tinted glasses. But this Oz isn't an illusion, it's a hyper-precise tool. In a 2025 paper in the journal Science Advances, the team described how the Oz system does something that sounds like sci-fi. It targets individual cone cells in a living human eye. Here's the simplified version. First, the system uses advanced imaging to create a detailed map of a person's retina, pinpointing the exact location of thousands of individual S, M, and L cones. It's like creating a personalized GPS for the inside of your eyeball. Then the real show begins. Using adaptive optics to correct for the eye's tiny imperfections and infrared light to track its constant, jittery movements, the Oz system fires microscopic pulses of laser light at specific, pre-selected cones. It can deliver up to 100,000 of these light, microdoses, every second, essentially playing the retina like a musical instrument, one cone at a time. Previous attempts to isolate cone signals were often imprecise or fleeting. Oz is different. It's direct, programmable, and gives scientists an incredible level of control over the very first step of vision. For the first time, researchers had a tool that could send a signal to the brain that nature simply can't. They could finally play that impossible note. The revelation: hello, Olo. With the Oz system ready, the researchers asked the driving question: what would a person see if you could stimulate only the M cones? If you sent the brain a pure, unadulterated, 0, 1, 0 signal, no red, all green, no blue, what would the impossible color look like? 5 participants, including some of the researchers, sat down before the machine. The lasers calibrated, the eye tracking locked on, and the system sent the signal. When asked to describe what they saw, their reports were fascinating and consistent. They described a color they'd never seen before. Some called it a profoundly saturated teal, or peacock green, a color so vibrant it made everything else seem pale. The researchers gave this new perceptual experience a name: Olo. The name, Olo, is a nod to its theoretical origin, the LMS color space coordinate, 0, 1, 0. To confirm Olo was a genuinely new experience, the researchers ran a color matching test. They asked participants to recreate what they saw using a standard, highly saturated monochromatic light. They couldn't do it. The only way they could get close was by taking the most similar available color and adding white light to it, a process called desaturation. This was the scientific proof. Olo was so saturated, so pure, that its perception existed beyond what could be created by normal light within the experiment. The moment the laser was misaligned even slightly, activating neighboring cones, the perception of Olo vanished, replaced by the ordinary green of the laser. This showed just how unique the experience was. It wasn't just a new shade, it was a whole new perceptual event, triggered by a neural signal that had never been sent before. A new reality. So, what does this all mean? Creating Olo isn't just a cool lab trick. It's a discovery that sends ripples through vision science and even philosophy. What if a new color isn't just about a new wavelength of light, but an entirely new way for our brains to process light? Scientifically, Oz and Olo are powerful new tools for probing the mysteries of vision. By programming artificial signals, scientists can study how the brain builds the rich, stable world we see from millions of simple, raw inputs. But the implications go deeper, touching on a classic philosophical thought experiment: Mary's room. Imagine Mary, a brilliant neuroscientist who has spent her life in a black and white room. She knows every physical fact about color, the wavelengths, the cone activations, the neural pathways, but she has never actually seen color. The question is, when Mary finally leaves the room and sees the color red for the first time, does she learn something new? The existence of Olo is a real-world spin on this question. You can understand the physics and biology, the laser pulses, the M cone activation, the 0, 1, 0 coordinate, but that doesn't let you experience the color. The 5 people who've seen Olo now know something new about the world, a subjective experience, what philosophers call qualia, that the rest of us don't. It suggests that a full description of the world might need to include not just physical facts, but also the subjective, conscious experience of them. Olo is a reminder that our inner world might be far richer and stranger than we can imagine. If your mind is racing with the possibilities of hacking human perception, do us a favor and hit that subscribe button. We explore the frontiers of science and technology every week, and you won't want to miss what's next. The future of sight. While Olo is a lab phenomenon for now, the technology that created it holds profound, if speculative, potential. The Oz platform is more than just a color generator. It's a programmable interface for the human retina. Imagine the possibilities. For some forms of color blindness where a type of cone is defective, could Oz be used to send new kinds of signals that restore a dimension of color perception? Researchers are exploring if this could work. Looking even further out, could this lead to a kind of tetrachromacy, the ability to see 4 primary colors, in a person with normal vision? Beyond color, this technology is a step towards high-fidelity visual prosthetics. By learning to speak the language of the retina, we could one day create devices for the blind that don't just send crude signals, but paint rich, detailed images directly onto the canvas of the brain. It even opens the door to a kind of direct-to-retina augmented reality, where digital information isn't on a screen, but woven directly into our perception. These are speculative, long-term goals, but the path to them starts with fundamental breakthroughs just like this. The discovery of OLO is a landmark moment. It's a testament to human ingenuity and our relentless desire to push beyond our natural limits. It shows that the reality we perceive isn't fixed, but is a construction of our brain based on the data it gets. And if you can change the data, you can change reality. We've spent our entire existence living within the sensory walls built by evolution. Now, we've found a crack in that wall. We've taken a step through the looking glass, seen a color created by technology, and opened up a universe of new questions. If you could use a machine like Oz to see one impossible thing, what would it be? Let me know in the comments below.